In the last lesson, we learned how to revert a table to a particular state according to the timestamp. However, that method is not quite precise. The more precise method is using the flashback to SCN, and this is the system change number. This is just a number that increases in the background of the database every time when some transaction has been performed, and regardless if that transaction was internal by the database or if it was initiated by the user. So for example, by some commit, rollbacks, drops, and other. We can find that SCN number at any time using the following query. This one uses the getSystemChangeNumber function from the DBMS flashback package, and when I execute it, we get the current SCN. Completely the same number we can get also from the vDatabase view, and the column name, the current SCN. So when I execute this, we are gonna get the same value. However, if you noticed, the number changed, as in the background, the database have been also performing some changes, and this SCN number has also changed. Again, there may be a chance that you cannot execute those two queries from the HR account, but you can grant those privileges from sys user, and those are the following commands. And don't worry, those are provided in the lesson resources. But let's proceed with our example. First, in my first session, I'm gonna create a table and insert just one row to it. So let's do that. So now my row is inserted, and I'm gonna initiate another session just by starting another SQL developer and insert the second row. So this is my second session. I'm gonna connect to the HR. We can check the current SCN. It has increased, and let's insert that data. So now my second row has been inserted. I'm gonna disconnect from this session, and I'm gonna initiate the third one. Again, on the HR, the SCN is again increased, and I'm gonna insert the third row, right? And again, I'm gonna disconnect from that database. Now, on the table, each of those rows has been inserted with a different transaction, which means that it should also have a different SCN assigned to each row. And we can check the SCN on any row on any table with the pseudocolumn ORA underscore row SCN. So when I query my table, which has now 3 rows, we can see that this SCN number is completely different for each row, as each row has been inserted in a different transaction. Now, I can revert the state of the table to a particular point in time, according to the SCN. So for example, if I want to revert to the state when there were only 2 rows, I can revert to the SCN with the following number. And I do that with the following syntax. It is flashback table, the name of the table, to SCN, and the number of the SCN. So I'm gonna execute this statement. My flashback has been successful. And now, if I check the state of the table, we can see that there are only 2 rows, as I have reverted to the particular point in time according to the SCN. Very nice. Under this lesson, we're gonna cover 2 more functions. And one is conversion of the timestamp to SCN and conversion of SCN to timestamp. So, for example, if I want to check what was the time on a particular SCN, I use the SCN to timestamp function, right? I'm just gonna pass in that number and execute. And we get returned the exact time of that SCN. However, as we mentioned that the revert to a timestamp is not very precise, we can prove that also with our nested functions, where I first convert the SCN to timestamp, and then again, I convert that timestamp to SCN. You would accept that my output would be completely the same as the input, as I'm just converting the SCN to timestamp and again the timestamp to SCN, right? However, if you check the results, we got 2 completely different numbers. So this is just another point to have in mind that is more precise to use the reverting with the SCN rather than with the timestamp. However, the most precise revert we can define by ourselves using the restored points, but more on that on the next lesson. See you over there.